In this video, we are going to review some questions in Unit 7. The first question is write as a single power, then evaluate. 6 exponent 2 times 6 exponent 3. Since the bases are the same, we're just going to add the exponents. So this becomes 6 exponent 2 plus 3, which is 6 exponent 5, and 6 exponent 5, if you use your calculator, is 7,776. Part B, negative 2 exponent 2 times negative 2 exponent 4. Bases are the same, negative 2, so we add exponents, so we get negative 2 exponent 2 plus 4, which is negative 2 exponent 6. If you use your calculator, negative 2 exponent 6 is positive 64. The next question says 5 exponent 10 divided by 5 exponent 7. Since the bases are the same and it's division, we are going to subtract the exponents. So we get 5 exponent 10 minus 7, which is 5 exponent 3. Use your calculator, you get 125. Part D says 1 over 3 cubed times 1 over 3 cubed. Bases are the same, so we add exponent, we get 1 over 3, 3 plus 3, which is 1 over 3 exponent 6. Now, we can distribute the exponent inside, so I get 1 exponent 6 over 3 exponent 6. 1 exponent 6 is 1. Any number, 1 to the power of any number is 1. 3 exponent 6 is going to give me 729. The next problem says 10 exponent 4 exponent 2. This is power to the power. So we are going to multiply the exponent. We get 10 exponent 4 times 2, which is 10 exponent 8, which is 1 with 8 0 beside it. The next one is negative 7 exponent 2 exponent 2. So we are going to write this one as negative 7 2 times 2, which is negative 7 exponent 4. If you use a calculator, negative 7 exponent 4 is positive 2401. Remember, base negative to an even number exponent is always positive. The next one, G, is 3 exponent 8 divided by 3 exponent 5. Since the bases are the same, we are going to subtract the exponents, so this is equal to 3 exponent 8 minus 5, which is 3 exponent 3, which is 27. H says negative 1 over 2 exponent 2 times negative 1 over 2 exponent 3. The same base, negative 1 over 2, and its multiplication, so we add the exponents, which is negative 1 over 2 exponent 5. Now I can distribute the exponent inside. I get negative 1 exponent 5 divided by 2 exponent 5. Negative number exponent to an odd number is always gives you negative, and since the base is 1, so you get negative 1 over 2 exponent 5 is 32. The next question says calculate the area of the square with one side equal to 3/8 of an inch. By definition, the area is for a square is just one side squared. So 3 over 8 squared. I distribute 3 inside. I get 3 exponent 2 over 8 exponent 2. 3 exponent 2 is 9. 8 exponent 2 is 64. So it's square inch. So the area is 9 over 64 square inch. The next problem says Evaluate and express your answer as whole numbers or fractions. Any number exponent 0 is 1, so 7 exponent 0 is 1. 5 exponent negative 1, we are going to change this one to a reciprocal and change the exponent to positive. So this is the same as 1 over 5 exponent 1, which is 1 over 5. Any number exponent 1 is the same number. 8 exponent negative 3 is the same as 1 over 8 exponent 3. And 8 exponent 3, if you use your calculator, is 512. Next question says 1 over 50 exponent 0. Again, any number exponent 0 is 1. So this is 1. Now 2 over 3 exponent negative 2. I can distribute negative 2 inside the bracket as exponent. So I get 2 over 2 exponent negative 2 over 3 exponent negative 2. 2 exponent negative 2 is the same as 1 over 2 exponent 2. And 3 exponent negative 2 is the same as 1 over 3 exponent 2. 1 over 2 exponent 2 is the same as 1 over 4. 1 over 3 exponent 2 is the same as 1 over 9. Now, I can write this one as 1 over 4 divided by 1 over 9 is exactly the same thing. Instead of using the line, I'm using the division symbol. Now remember, to divide two fractions, we flip this one and then you change division to multiplication. So this is the same as 1 over 4 times 9 over 1. When you multiply fractions, you multiply numerator, so 1 times 9 is 9, 4 times 1 is 4. So the answer is 9 over 4. The next one is 4 exponent negative 2 times 4 exponent 5. Since it's multiplication and the base is the same, so I'm just going to add the exponents. This is the same as 4 exponent 3. And if you evaluate it using your calculator, 4 exponent 3 is 64. The next question is 7 exponent 2 divided by 7 exponent 3. Same basis division, you subtract exponents, so it's 2 minus 3, which is 7 exponent negative 1. When you're dealing with negative exponents, you write the reciprocal with positive exponent, which is the same as 1 over 7. The next one is negative 3 exponent 2 exponent negative 1. We multiply the exponents, so we get negative 2. This is the same as the reciprocal with positive exponents. Now remember, any negative number exponent, even number is going to give you positive. This is the same as 1 over 9. The next one is 1 over 2 exponent negative 3. Remember, I can write it as 1 over 2 exponent 3, which is 1 over 1 divided by 2 exponent 3 is 8. I can write this one as 1 over 1 divided by 1 over 8. Remember, 1 can be written as 1 over 1. This is the same as 1 over 1 times 8 over 1, which is 1 times 8 is 8. 1 times 1 is 1, so the answer is 8. The next one is 1 over 5 exponent negative 1. I can write it as 1 over 5 exponent 1. Any number exponent 1 is the same number, so it's really 1 over 5. This one, I can write it as 1 over 1. Numerator, I can write it as 1 over 1 divided by 1 over 5. Division, you flip the second fraction and then multiply. So you write 1 over 1 times 5 over 1. 1 times 5 is 5. 1 times 1 is 1. So the answer is 5. The next question says, which graph represents an exponential relationship? Explain. We start with C. C is not a exponential because it represents a linear function. So this is not. Then we go to B. B represents a quadratic. This is not. But A is an exponential relation. Now, as you can see, when we go from left to right, the values of y is increasing. So we can say this is exponential growth. The next question says a certain type of bacteria doubles every 8 hours. The culture begins with 30,000 bacteria. How many bacteria are there after 8 hours? Remember that bacteria, they double every 8 hours. So you want to know how many are there after 8 hours? I just multiply this one by 2. So here we get 30,000 times 2, which is 60,000. The next one says after 16 hours. We know that 16 hours is 2 8 hours. So this means that 30,000 is going to be doubled twice. So it's going to be 30,000 times 2 times 2, which is going to be 120,000. The next one says after 4 days. I have to see how many 8 hours I have in 4 days. Remember, one day is 24 hours. And yet 24 hours, okay, if I have 4 days, so the number of hours is 4 times 24. Now the question is that how many 8 hours I have in 4 times 24. So I divide this one by 8. 24 divided by 8 gives me 3. 3 times 4 is 12. So this means I have 12 8 hours in 4 days. Every 8 hours I'm going to double. This means that my population becomes 30,000 times 2 exponent 12. Now, if you evaluate this one, you get a huge number, which is 122,880,000 bacteria. The next question says, compare the graphs of 3 exponent x, 3x squared, and 3x for values of x equal to -4, -3, -2, -1, 0, 1, 2, 3, 4. Specify what are the similar things about these 3 graphs and what is different. So obviously we are going to go and use Desmos. Now, because I have to plot the graph for specified points, I have to use tables. As we did before, we just gotta click on plus and then table. Now my table of values, based on the problem, they start from -4, -3, and then it continues until 4. So here I'm going to type 3 exponent x1. It's going to evaluate 3 exponent x1 when x1 is any one of these values, and this is going to be my graph. Now let's do 3x squared. So I'm going to say 3x1 exponent 2. These are the values for every x1 here, and the color is blue, and you can see this is my quadratic. And the last one is 3x1. This is the graph of 3x1 again. Now let's look at the similarities. The first similarity is that every one of them, they go through the point 1, 3. For instance, the exponential one, when x1 is 1, y1 is 3. For 3x1 squared, the quadratic, when x is 1, the quadratic is 3, and for linear is the same. So this is one of the similarities. They all go through the same point, 1, 3. The other similarity is that you cannot find here any x value which has different y values. For instance, let's look at this exponential one. When x1 is -4, the only y value that you have is this one. You cannot find anything else in this table of values. And the same is true for quadratic and linear one. Now let's talk about the differences. One of the differences is that the linear one is the only one which has negative values. None of these, they have negative. They are all positive here. That's one difference. The other difference is that the quadratic is the only one which is symmetric about the y-axis. Look at the quadratic here. Or I can show you here. This is the quadratic, the blue one. You can see that the quadratic is symmetric about this line. The linear and the exponential are not. In the next question, we have the measure of acidity of a solution, which is called pH. In wells and swimming pools, the pH level of water needs to be checked regularly for the level of hydrogen. The equation, which is here, represents an indication of the concentration of hydrogen ions, H, in moles per liter. The first part of the question says, plot a graph of this relation. So obviously we're going to go back to decimals and try to plot this. So again, we're going to type the equation. H is equal to 1/10 P. This shows the graph of relationship between hydrogen ion and pH. You can see that, first of all, P is on the x-axis and H is on the y-axis. You can see that hydrogen levels, they decrease as the pH increases. You can also see that this is an exponential function because going from left to right, the y values are decreasing. The y values, meaning h values here, are decreasing. This is an example of exponential decay. The next part of the question says, water with a pH of less than 7 is acidic. What is the hydrogen concentration for a pH of 7? We are going to use the formula given above. So we're going to say that H is equal to 1/10 exponent 7. But 1/10 exponent 7, I can write it as 10 exponent -1 exponent 7. Now it's power to a power, so I multiply them together. So this is the answers. 10 exponent -7 moles per liter. The next question says, water in a swimming pool needs to be kept at a pH level between 7 and 7.6. What is the equivalent range of hydrogen concentration? So 1/10 exponent P, let's say 7.6. This is going to give us 10 exponent -1. I change this one to negative exponent 7.6 which is equal to 10 exponent -7.6. You multiply the exponents now. If you use your calculator, this is going to be 25 times 10 exponent -9 moles per liter. And previously, we found that for 7, we got 1 over 10 exponent 7, which is 10 exponent negative 1 exponent 7, which is 10 exponent negative 7. So this means that our hydrogen is between 10 exponent negative 7 and 25 times 10 exponent negative 9. The next question says that the rainwater has a pH of 5.6. Due to sulfur pollution, acid rain has a pH of less than 5. Compare the concentration of hydrogen in rain and acid rain. When the pH is 5.6, let's find what is the hydrogen ion. So we are going to say H of rain is 1 over 10 exponent 5.6, which is the same as 10 exponent negative 1, 5.6, which is 10 exponent negative 5.6. Use your calculator, and if you use your calculator, you get 0.00002512 moles per liter. Now, acid rain has a pH of less than 5. So let's say H of acid rain, AR, is 1 over 10 exponent 5, which is 10 exponent negative 1 exponent 5, which is 10 exponent negative 5, which is going to be 0.12341. So this means that the concentration of hydrogen is somewhere between this number and this number.